Hello, and welcome to our channel. Today we have an exciting update on China's lunar exploration program. The Chang'e-6 mission has achieved a remarkable milestone by successfully landing on the far side of the Moon. Let's dive into the details of this groundbreaking mission. The Chang'e-6 lander made a soft landing on June 1st at 6:23 p.m. Eastern Time, 22:23 UTC, as announced by the China National Space Administration. This historic landing took place in the southern part of the Apollo crater within the South Pole-Aitken Basin, a region of significant scientific interest. The South Pole-Aitken Basin is one of the largest and oldest impact basins on the Moon, making it a prime location for scientific exploration. The samples collected from this area are expected to provide invaluable insights into the Moon's history and geological evolution. The Chang'e-6 mission is China's fourth successful lunar landing and the second on the far side of the Moon. It also marks the third lunar landing of 2024, following Japan's SLIM mission in January and Intuitive Machines' IM-1 Odysseus lander in February. This achievement underscores China's growing prowess in space exploration. The Chang'e-6 lander utilized a variable 7,500 Newton thrust engine to slow its descent in lunar orbit. At around 2.5 kilometers above the lunar surface, the lander began rapid positional adjustments. It then entered a hovering phase at approximately 100 meters above the surface, using light detection and ranging, LiDAR, and optical cameras to identify a safe landing spot. This precise maneuvering was crucial to ensuring a successful touchdown. Now let's talk about the mission's objectives and the sophisticated equipment on board. The primary goal of Chang'e-6 is to collect up to 2,000 grams of lunar samples, including surface regolith and subsurface material. To achieve this, the lander is equipped with a scoop and a drill. These samples will be critical for understanding the Moon's composition and its volcanic activity. This mission builds on the success of previous Chang'e missions. For instance, Chang'e-4, which landed on the far side of the Moon in 2019, provided groundbreaking data about the lunar surface. The ongoing analysis of Chang'e-4's rover data continues to yield exciting discoveries, and Chang'e-6 is expected to further enhance our understanding of the Moon. Expert commentary by Xu Yi, assistant professor at the Macau University of Science and Technology, told, "I have been analyzing the scientific data of the Chang'e-4 mission, and I am constantly excited by new findings from the ongoing rover data. The Chang'e-6 mission will likely collect samples from various sources, including products of local volcanic activity. This will help us understand the reasons for the asymmetry in volcanic activity between the lunar near side and far side." After the successful landing, the Chang'e-6 team will begin initial checks of the lander's systems. The sample collection process is expected to start shortly thereafter. The lander will use a scoop to gather surface material and a drill to collect subsurface samples, providing a comprehensive set of data from the landing site. Once the samples are collected, an ascent vehicle will launch from the top of the Chang'e-6 lander within approximately 48 hours. This vehicle will carry the samples into lunar orbit, where it will rendezvous and dock with the waiting Chang'e-6 orbiter. The samples will then be transferred to a re-entry capsule for their journey back to Earth. Communication with the far side of the Moon is a challenging task, but the Queqiao-2 relay satellite plays a crucial role in this mission. Positioned at a stable point beyond the Moon, Queqiao-2 facilitates continuous communication between the Chang'e-6 lander and mission control on Earth, ensuring the smooth execution of mission operations. The timeline for the mission's next steps includes the launch of the ascent vehicle, the transfer of samples to the orbiter, and the journey back to Earth. The re-entry capsule is expected to land in the grasslands of Inner Mongolia around June 25th, where the samples will be retrieved and transported to specialized facilities for analysis. In addition to collecting samples, the Chang'e-6 lander carries several scientific payloads from international partners. These include the negative ions at the lunar surface, NILS payload developed by the Swedish Institute of Space Physics and the detection of outgassing radon DORN instrument from France. An Italian passive laser retroreflector is also aboard the lander. A small rover is expected to be deployed for short-term operations, conducting further experiments on the lunar surface. Chang'e-6 is a crucial part of China's broader lunar program. Looking ahead, China plans to launch Chang'e-7 in 2026 and Chang'e-8 around 2028. These missions aim to explore the lunar South Pole and lay the groundwork for establishing a permanent lunar base. This ambitious project, known as the International Lunar Research Station (ILRS) program, is scheduled for the 2030s and involves collaboration with various countries and organizations. The success of Chang'e-6 is a significant milestone in lunar exploration, and we eagerly await the wealth of scientific data it will provide. Be sure to subscribe to our channel and follow us for more updates on this exciting mission. Thank you for watching, and see you in our next video. We are thrilled to share this exciting lunar journey with you. If you have any questions or comments, please leave them below. Goodbye, and stay curious.